The paper we want to discuss in this video is titled Transformers as the Statisticians, Provable In-Context Learning with In-Context Algorithm Selection. This paper is from Salesforce's AI research and is published on arXiv on 7th of June 2023. When talking about transformers in large language models and foundation models, the concept of in-context learning is something that you see people talking about a lot. The idea is that your model, which is a large transformer when thinking of things such as GPT-3, you can provide it with a few examples in the input side of it, and it could take those examples that comprise a few-shot learning setup, and it could do, based on those examples, a new task for you on an input, and it could produce the correct outputs for you. This work focuses on transformers and shows that the transformers can embed these kind of knowledge in themselves and implement a broad class of standard machine learning algorithms such as least squares, rich regression, convex risk optimization, lasso, and gradient descent. This is the setup for training a transformer to perform the in-context learning. Like, the idea is that you would have a dataset D, a distribution D, where you sample, let's say, a data set x1 to xn, and you also provide it with an xn plus 1, which is the test item on which the transformer is supposed to operate. Now, the difference from the general supervised learning is that each instance, each item that you're training this on is going to be sampled from a different distribution D, so you don't work with a single distribution. In section 3, they show that transformers can learn a lot of basic building blocks of machine learning in the in-context setup. And in segment 4, they discuss that transformers can perform these types of in-context algorithm selection. They design and follow the protocols of post-ICL validation and pre-ICL testing and show that basically transformers can follow these types of mechanisms and learn to do this algorithm selection in the in-context learning setup. For example, in the post-ICL validation, you can see that data can be split into train and validation. The different algorithms can run on them. You can check the different losses, and by comparing the value of these losses, you could select the algorithm to use on the test example that is given to it. They show the great performance of this algorithm selecting transformer as well, compared to, let's say, transformers that are trained via a specific task. For example, the classification one, it could be shown that they work well on the designated task but not well on the other one. For example, classifier does not do a good job on linear regression. This concludes our video. However, the original manuscript is 93 pages and very long, and there's a lot more to its theoretical results and experimental results, so I really suggest you reading it. Thanks so much for watching.